Hello, folks. Welcome to Rational Science, directly from Frankfurt, Germany. The only site on the internet that does physics. Everybody else does math. They call it physics. Anyways, today on our show, we're going to have three parts. First part, we're going to do a little bit of extinction. Quite popular subject, really. And second part, we're going to do a little bit of physics. Today we're going to be dealing with Schrodinger's cat. Is that cat still around? Is he dead or alive? I mean, let's find out, right? And then the last part, we're going to do questions and answers, questions really and comments that people made since the last time. Now, incidentally, I usually don't answer things real time. And because some of the questions that people ask require an elaborate answer. And so I want to give them a good answer. And for that, you really want to investigate what the guy is up to. Sometimes they put a link, or sometimes they say, talk about a subject and you don't know really what they're referring to. So, you got to do a little bit of research to answer the questions correctly. Anyways, once a month I do get together with my son and we do real-time, live questions and answers. Okay, let's get on with it, with extinction. And the subject of today, the first subject, comes from a person who put a comment. And he says, diversity of species already on the downgrade before the asteroid hit Earth. And another fellow doubled up on that and says, there's an article about the Cretaceous extinction on BR, German TV station. It seems mainstream science is catching up. So I looked it up, see what they're referring to. I guess they were both referring to the same article. Maybe they read the same article. And it came out about a week ago. And this is the article. Let me get it up here. Article, what is it, the 29th of June, 30th of June, says dinosaur biodiversity declined well before the asteroid impact, influenced by ecological and environmental pressures. Okay, and so they go on and they mention what happened about 10 million years. They looked at the last 10 million years prior to the Cretaceous, the KT extinction, the dividing line, which was anywhere, they don't know exactly, it's 65 million to 66 million years ago, somewhere around there. I want to call your attention to one of the persons on the list there, and that's that third one, Michael J. Benton. Okay, he's kind of like the dean of paleontologists in this realm, in the KT extinction, also Permian and so on. He's been around for a while. And he wrote a paper, a 30-year-old paper. I've discussed him in the past, but he wrote a paper in 1990, okay, which I recommend that anyone who wants to, come into the field and just get an overview. I think it's an excellent paper. And that paper deals with the history of extinction theories. Okay, here's the paper. Scientific Methodologies in Collision, the History of the Study of the Extinction of the Dinosaurs. And it's a good paper because he does a pretty good job of going through and figuring out, what the different theories were throughout time. So, it's like a must read for anyone who gets into this subject. Anyways, he essentially puts two models or two groups of people. We have the gradualist on one side and the catastrophist on the other. The gradualist is a person who says, these things happen over time, the loss of diversity of species, the decline, the slow decline of in other words, they were losing more species as time went by. And the causes are assigned to competition, declining temperature, and marine regressions. The last two, primarily from a fellow named as Robert Baker. I've talked about him in the past. And Baker wrote a book which I also recommend, The Dinosaur Heresies. Very good book, primarily because he does a lot of theory in there. He goes into mechanisms. I don't agree with some of Baker's conclusions, especially, but the book is good anyways. It's a good read. Very thick book, but it's a good read. Why? Because Baker goes in there and, again, goes into mechanism, which is what it should be, for anyone who enters this field. Anyways, Benton contrasts the gradualists against the catastrophists. And who are these people? Well, they believe, as far as the dinosaur extinction, that it all happened through an impact of an asteroid. Okay, and he goes in there and says, dust cloud which blocked out the sun, prevented photosynthesis. Okay, and so I guess all the plants died or something like that. In fact, some people say that, exactly that. And so it's got to do with the atmosphere and also with thermal stress. And I synthesize it at the bottom. You see it there on the left-hand side. I said competition and climate change is essentially what the gradualists propose, and the catastrophists propose catastrophes and environmental changes, sudden changes. Okay, so this is essentially the fight, you could say, between that's been going on for a long time. I would say since the days of Georges Cuvier, 200 years ago, we had these two groups. Some people who say it happened gradually, the extinction of animals. The otherwise said, no, it happened suddenly. Okay, and so who is right? Do we have enough facts to determine who is right? Okay, that's one of the things you want to keep in mind today. Anyways, I don't think Mr. Benton wrote anything important after that. He never contributed anything at all other than that paper to paleontology. You say, Bill, how can you say that? What are you saying? This man's been around for so long. He's a paleontologist. He's an expert in his field. And before we can really say that and assign authority, we have to figure out what a paleontologist is. What is paleontology? What is paleontology about? And here we look up a definition, and we find in the National Geographic, the study of the history of life on Earth as based on fossils. Wikipedia says the scientific study of life that existed prior to and sometimes including the start of the Holocene epoch. Includes the study of fossils to classify organisms and study their interactions with each other and their environments. Okay? And you look at dictionary.com, says, what is a paleontologist? It's a scientist who specializes in the study of life forms that existed in previous geologic periods as represented by their fossils. Is that what a paleontologist is? Is that what paleontology is about? And no, the answer is no. Those definitions are not scientific. And I'll tell you why. Science is not the study of. It's not the study of anything. Science is about explaining. You have to explain something. So you studied, and you know nothing. You understood nothing. Does that make you a scientist? You studied for the test on Friday, and you got every question wrong. You got a 0 on your test. Does that make you a scientist because you studied? People have this notion that came from the 17th century so-called scientific revolution that says that, science is an ongoing process. No, absolutely not. Science has nothing to do with a process. Science has to do with explain something. That's when you have to burn your calories up here, your gray matter. But to say that you studied and then you come up with some nonsensical theory, explanation, Mother Nature laughs at such so-called scientists. And so, no, what is paleontology? What is this field about? Well, here it is. Paleontology, the branch of science that rationally explains extinction. Okay, paleontologist is a medical examiner. He's a forensic pathologist, a scientist who determines the cause of death of ancient species. In other words, extinction of plants and animals. Okay? That's what a scientist is, especially a paleontologist, right? Paleontology, you have to explain death. You have to explain how animals in the past died, or plants as well. And if you cannot explain that, what do I care if you studied, you collected stuff? Some people have this idea that a paleontologist is a guy that goes out there in the middle of nowhere and starts breaking the rock, pulling bones out, dusting them off, assembling them, giving them a fancy name, and putting them in a museum. No, that's not a paleontologist. As Mr. Ernest Rutherford would say, that's a stamp collector. Paleontologist has to tell you something about the death of animals and plants and animals in the past. Once we're done with that, we're done with paleontology for the rest of humanity, for the rest of our history, for the rest of our existence. And anyone who wants to go in there and look at more bones and classify them, they can do that. That part is very specific, and those are specialists who dedicate time to that. The important thing from paleontology is extinction. Once we got that, people don't want to hear all the little details about measurements and how big the tooth was and all these things that you see in the literature out there. We need an extinction theory, and we don't have any extinction theory on Earth today. Okay, for 200 years we've had this discipline known as paleontology, and not one person today can tell you how the woolly mammoths became extinct, how Neanderthal became extinct, how the T-Rexes became extinct, how the mammal reptiles became extinct. No one has a theory of extinction, a foolproof extinction. And you say, well, there's lots of theories out there, El. I mean, what are you talking about? There's only one thing that an extinction theory has to explain, and that is selectivity. If you have not explained selectivity, you do not have an extinction theory, and if you don't have an extinction theory, you're not a paleontologist. We have no paleontologists on planet Earth today. And part of that has to do because, all these people, they go through the courses at the university, and if they want to graduate, they can't buck the trend. They have to toe the party line. They have to publish whatever the previous generation, who are the peer reviewers, want them to publish. So even if they have a bright idea out of the norm, they can't publish it because they would be considered, outside the norm. No, you can't buck the trend. You have to toe the party line if you went through that channel. See, in my case, I don't have to worry about that because I don't know these people anything. I can give you a theory, and does it mean you're going to believe it? No, that's not the point. The point is that I give you a theory so that you can think about it, so that you can reach your own conclusions. But I'm not going to just repeat what all these people do, which is what the previous generation has already figured out, proved, and all they do is regurgitate from one generation to the next the same thing over and over and over again. We've had the same theories for the last 200 years. Okay, and so here's this theory these people came up with. Okay, see if I can get this up here. Okay, and this is what they say in that paper. The most important part, probably, that I sifted out. The question why non-avian dinosaurs went extinct 66 million years ago remains unresolved. Already their paper starts out on the wrong foot. They're saying, we don't know. After 200 years, we still have no idea why the dinosaurs died. They're telling you that in the first sentence of the paper. Okay, so let's see. The biodiversity of non-avian dinosaurs would have been declining 10 million years before they were finally extinct. Apparently a gradualist here, right? Not a catastrophist. Okay, but it was the impact of an asteroid that killed them off. I like that. You got to be at peace with both God and the devil. Okay, so you shake hands with both of them, you know, and you say, "Yeah, Mr. Devil, I shake your hands in case I happen to go to hell, and I'll shake hands with God as well," you know. Okay, the mighty asteroid, which today is testified by the Chicxulub crater in Mexico and a thin layer of iridium all over the world, would have changed the climatic conditions of the Earth so abruptly that the habitats of the non-avian dinosaurs were destroyed. So what are these fellows going to talk about? Well, you're going to talk about an asteroid that caused some climatic catastrophe, some sudden change in the climate, possibly, you know, the dust that covered the entire Earth, that blocked out the sun, that prevented photosynthesis or normal photosynthesis. Okay, so this is where this paper is going. The climatic conditions. Okay, it says the non-avian dinosaurs did not have the necessary biodiverse and evolutionary tools to recover as a class from the asteroid impact. You have to give, pay homage to the asteroid theory. Otherwise, you don't get your paper published. That's how simple it is. See, I don't have to worry about that because I don't suck up to all these people. So I can give you a theory, and you got to find it like a needle in the YouTube haystack to find me. But once you get here, at least you're going to listen to something that you can sink your teeth into. And so, okay, so it says they could not recover a combination of global climate cooling, okay? The diversity of herbivores and an age-dependent extinction had negative impact on dinosaur extinction in the late Cretaceous. These factors impeded what? Their recovery from the final catastrophic event, meaning the asteroid. So they couldn't recover. Otherwise, you know, they would have recovered. This is what they're suggesting. Like many say, if that asteroid hadn't hit the Earth, in fact, someone said that in one of the comments, the asteroid hadn't hit the Earth, the dinosaurs will still be around in New York City. My God. Okay, let's find out. What's wrong with this? Because here they're saying the last 10 million years, there was a decline in species. Some of them, because apparently the hadrosaurs expanded. That's what they're going to argue. Their numbers expanded at the expense of others. Okay, but what's the issue here? The issue here is the little fable that I tell about the last 5 Neanderthals. And yeah, it's a fable because the Neanderthals were animals. And so I think I'm okay by saying it's a fable. So you get the last 5 Neanderthals on Earth. And they're in a cave. And they're around a campfire. There's this big boulder. Rolls down and kills all 5 of them. Okay? So now someone asks, well, Bill, how did the Neanderthals die? And I say they died by rock. They rocked. A boulder fell on them. That's how they became extinct. Now, is that a valid theory? No, it's not a valid theory because you have to explain how we ended up with 5 Neanderthals. That's the extinction theory. Not the nonsense that a boulder, just by sheer luck, fell on their heads. And that's more or less what we've got here. These people here in this paper, they say for 10 million years, the dinosaurs were declining. And then came this asteroid out of nowhere. An act of God. You know, God threw the asteroid to the Earth and just wiped them out. You know, the straw that broke the camel's back, so to speak. Well, no, we don't care about the asteroid. Because if the asteroid fell to the Earth, it couldn't have been the cause of the demise of the dinosaurs if the dinosaurs were becoming fewer and fewer and fewer in the last 10 million years. We have a little contradiction. The theory is, how did we end up with few dinosaurs? Not what was the boulder that killed, the last 5 Neanderthals. That's not a theory. And so we have to find out why The real cause of extinction has to do with why we ended up with fewer and fewer dinosaurs. That's the theory. Okay? And so, yeah, I got a problem with first, this middle position. And second, to cover all the bases. Well, it was climate change, it was competition, it was also the asteroid. You know, we put them all together, and boy, that paper's got to be approved by the peers because everybody's happy. You know, the peer who believes in climate change, he'll like it. The guy who believes in the asteroid theory, he'll like it. You know, everybody likes it. And what is all this for? Is this for science? Or is it to get your name in lights so that you can make more money, make a career? And see, this is the problem we've got in science in general, paleontology in particular, and that's that, you know, you have to bow down to the previous generation. And so it turns out that the working hypothesis, the foundation, always starts from the previous generation. You can't buck the trend because you don't get published, you don't have a career, you don't have any money. If you want to be up there, you want to get your name in lights, you have to start, you know, first by paying homage to the previous generation. And so we've got a series of this for 200 years now, probably less than that, but certainly after World War II, we've had all these theories where one guy just depends on the other guy, who depends on the other guy, who depends on the other guy. And so we can never get out of that because the system that we've created for science does not allow for new theories, for new proposals. That's the problem. And so you're always going to hear the same thing over and over again. From now on, it's going to be, well, the asteroid was not red, it was blue. It was a little bigger, it was a little smaller, and we measured this little... I mean, what is that? That's science? The theory is, what? How did the dinosaurs die? Did they die by comet, or did they die for 10 million years gradually? Which is the theory? And when you put it all in there, it's just, all you're doing is sucking up. That's all you're doing. Okay? So how do we explain extinction? In comparison, in contrast, here at this site, okay, we do it a little more rationally. Okay, and so we start by mentioning the following. This is how Mother Nature does extinction. Okay? And she looks at the vitals, what I call the vitals. Breathing, drinking, eating, sleeping, and aging, and loss of genetic diversity. Those are the things that none of us can avoid. Species cannot avoid. Okay? In other words, you need to breathe. And I think we can take that one for granted, even though paleontologists out there, you know, the ones who believe in supernovas, they say that the air was taken out of the earth momentarily, waited for some of the animals to die, then the air came back. You know, we received this big shot from a supernova. It comes from NASA. NASA loves all these extraterrestrial causes because, you know, they've got a big stake in it. And so they give money to all these researchers to provide extraterrestrial evidence, proof, so that they can continue the cycle. That's what it's all about. There is no chance whatsoever of an extraterrestrial, especially a supernova, you know, having caused any of the extinction. In this case, it was the Ordovician. Okay. But those are the vitals. That's what Mother Nature's going to tackle. She's going to get you through one of these. And we're going to eliminate breathing because we're saying, hey, breathing, I think that's, until someone bottles the air, I think we're all safe there, okay? Sleeping, well, again, I think that's not where the issue is. Aging, yeah. Aging and low genetic diversity, those are the causes of a background extinction. Neanderthals. And for us, and for all mass extinctions, drinking and eating. And yeah, one of the reasons that none of these paleontologists today have figured out that we are the last generation of humans on Earth is because they're blindsided. They have no clue what causes extinction. See, if they would have figured out how extinctions happened in the past, they would realize that we are the last humans on Earth. I mean, how long do we have to go? I don't think we have 30 more years to go. I don't think we'll make it to the mid-century. That's my personal take on that. I can't tell you, I can't give you a date, but we're about to become extinct as a species. All mammals, in fact, the whole order essentially will disappear. Yeah, this century for sure. There's no way we can survive this century. And why? Well, because Mother Nature is going to attack us through what? Drinking and eating. Two vitals. If you don't eat, you're going to die. If you don't drink, you're going to die. So it's a guaranteed thing if we remove eating from all humans on Earth, if we remove drinking from all humans on Earth will die. Believe me. Don't take my word for it, but believe me. Okay, so how does the theory start? Well, I usually like to say that imagine you're at the starting line of the Cambrian, 542 million years ago, or thereabouts. Obviously, there were animals before them, Precambrian, but let's start at the Cambrian line, just arbitrarily, not important. We can predict retroactively now, okay? We can predict what's going to happen. Retroactively because we've already mapped it out in general terms, in the big picture. We have the big picture. We don't need any more evidence. We've got too much evidence as it is. We already have the evidence we need to determine what caused extinction. Okay? And if you're standing at the Cambrian starting line, 540 million years ago, and you look forward, you can predict, retroactively, right? You can predict that periodically plants are going to disappear. When, not if, but when plants, orders, entire orders disappear, the animals that forged a relationship, for millions of years, right? Relationship with those plants will disappear with them. Now, why have the so-called paleontologists figured that out? Well, because the worldly wisdom among them is that, well, an animal just switches from one food to another. So if he can't find this kind of food, especially a herbivore, can't find, I don't know, grasses, he'll switch over to some other food, some other plant. That's the worldly wisdom. And what they're saying is that, you have a rabbit, and this rabbit cannot find lettuce, and so he's going to switch overnight to pine leaves, Christmas trees. Is that true? Is that how it works? Do rabbits switch from lettuce to pine leaves? Can a rabbit digest conifers? And no, the answer is no. The animals don't switch at the last moment when something happens in the environment. They say, oh, I can't find some of this, I'll eat some of that. It doesn't happen that way. Can you eat can you eat conifers? Can you eat ferns? The answer is no. We don't eat ferns, we don't eat conifers. We eat angiosperms. Okay? And so now imagine an animal, I don't know, in the Permian. And Permian had really two big extinctions. The first half, they had all these sailbacks, lizard-like looking animals like Edaphosaurus and Dimetrodon. Second half, they had other types of mammal-like reptiles, which were like the gorgons and the Brachiosaurs. First guys looked like lizards. The second guys looked like lions and tigers. They laid eggs. A lion laying eggs. Yeah, that's more or less what it was. So there was an extinction 252 million years ago. So they say that's more or less the date they've got. And it turns out that, one of the plants that covered essentially most of the planet was the Glossopterids. There's Glossopterids, there were different species of these, but they covered the land. They were seed ferns. Okay? And when these plants went away, just by sheer coincidence, the land animals also went away. Now, isn't that a coincidence? And then you got the Triassic, you have Dicrodiums, another seed fern, which was the end of the seed ferns, by the way. And that's when the Archosaur era came to an end. Now that's another coincidence, isn't that? And yes, it turns out that all mass extinctions have a major plant that is slowly, essentially dying towards the last few million years. And I call it the shrinking island theory. The island, jungles, the forests of whatever, is shrinking. And the animals, the herbivores that depend on those plants, they cannot diversify, they cannot expand, they cannot radiate like it did millions of years earlier, their forefathers. Now it's the opposite direction. Now they've grown big through Cope's law. Cope's law means that animals grow big through this arms race typically over time. So they become big, they become numerous, they have fewer children. Okay? And so what do you have? Well, you have first the density dependent issue, okay, density dependent birth rates. Then you have the expansion of big animals that are growing and expanding on a shrinking island. The jungle of what they eat, right, is shrinking and they're expanding. And so, yeah, at some point there's got to be a crisis. Okay. Now, why did the plants disappear? Why are they shrinking? Is it because of climate change, like all these people say? Is it because an asteroid or volcanoes hit the Earth or sprouted plumes from underneath the ground? I don't know, geysers. They can only think of catastrophes. It never occurred to them that plants have their cycle too. All plant species, all orders must disappear. You say, how do you know that, Bill? Well, we know that because that's the history of life on Earth. And here, let me show you the history of life on Earth in a nutshell. Okay, here it is. Okay, this is the big picture. Okay, what you have is the Carboniferous. You had all these amphibians, and it was the age of maybe non-vasculars and early vasculars. When you get to the Permian and Triassic, you get the age of ferns and seed ferns. The age of synapsid, really, of mammal-like reptiles. Then when you get to the Jurassic and Cretaceous, you get the dinosaurs. What did they eat? Well, what do you think they ate if the land was covered by gymnosperms, conifers? And what do we eat today? Well, what's out there? Well, what's out there is angiosperms. That's what we eat. We don't eat gymnosperms, and we don't eat ferns because there was a type of animal that thrived with ferns, another type of animal that thrived with gymnosperms. And you say, well, how did these disappear? I mean, was it by magic? Was it, again, some kind of climate change, which is the only thing these people can think of? Because it's very popular today, in our world. You say, oh, climate change, we've got to do something about it. So all they can think of is climate change, and they know they're going to get their paper published because they just mentioned the term climate change. And so this is all they can talk about. And no, here it is. Let me show you. This is the mechanism, okay? Call it overturning of the demographic pyramid, okay? And so, yeah, when the demographic pyramid of plants overturns, of orders, of species, even of individual plants, that's when they die. That's when they become extinct. So plants periodically became extinct when they lose genetic diversity. They've been inbreeding for millions of years, right? They've been sending their pollen or whatever, cones or spores, right? So they've been inbreeding for millions of years. Now the Amish have been doing that for 300 years, and now they're having all kinds of physical and mental problems. Okay, after 300 years, they started out with what, a few hundred, and today they're like 300,000. And yeah, now they're starting to have problems. And this is what happens to the plants, but in a million-year period. What happens towards the end, their population pyramid overturns because, again, they become big. One of the clues. Become big, old, they live to long ages, nothing kills them anymore, they become accustomed to endemic diseases. Okay? They manage to reach a truce with the diseases that used to kill their forefathers. Those that survived had defenses, passed it on to their offspring, and by the time you get to the end, not only these plants are no longer migrating, they become sedentary. They're in a region of the planet. That's when they make their last stand. They're big, typically. They're resistant to diseases because the endemic diseases no longer kill them, maybe makes them sick at most. And they also begin growing vegetatively instead of by seed. Okay? So what happens is the population pyramid of plants overturns. And guess what happens to the animals that depend on that shrinking island? Well, they disappear. And that's the overturning of the ecological pyramid for the animals. Okay? And that's what we're proposing. And I presented this in a paper sponsored. There was a conference sponsored, 2016 by Oxford University in Prague, Czech Republic. I presented that paper there. I also presented the paper 6 years earlier in 2010 in Aberdeen, Scotland. But nobody reads it. Why? Because I'm not part of the establishment. And certainly I'm not going to talk about climate change, asteroid strikes, or any other extraterrestrial strike. Competition, never even mention it, has nothing to do with extinction. No, this has to do with internal, it has to do with the vitals. It's an internal thing to every species. And it's going to happen to, all, it has happened and will happen to all species that manage to survive the upcoming extinction very soon, which is the extinction of the mammals. Okay, so that's the theory, and that's what I propose in exchange to what these people propose. Let me show you that they had also a lot of evidence already. I mean, they could figure this out. They never did. I don't know why. Here's the Cretaceous terrestrial revolution. This was what happened during the Cretaceous. And it took them like 4 years to assemble all this information. So this is pretty solid evidence, I think. So for those who like evidence, well, here you have evidence. What happened during the Cretaceous? Well, what you see is the angiosperms muscled aside the reigning plants, the conifers. That's essentially what happened. Okay? Not only the number of species, but the quantity of individuals, you could say, right? Quantity of plants. Also, it changed the landscape. Was it because of climate change? No, absolutely not. As you can see there to the conifers, they had grown all the way to Cretaceous, and then they followed what I call the curve of life. Okay, here's the curve of life. Okay, this happens to all life essentially. That's the curve of life, and it goes to a peak, and then it comes down. First part, millions of years, when they're battling diseases especially, and predators and so on. Well, you have births that are greater than deaths, or approximately equal. Then you get to the stage where births are greater than deaths. Then, when the pyramid starts overturning, this is the population pyramid, births are less than or equal to deaths, and finally, births are way fewer than deaths. That's the curve of life. And that's what happened here. Okay, this is what you see there. That's the curve of life right there. For you look at the conifers, you can see how they have that little hump there, and that'll give you an idea of what happened in the Cretaceous. While the conifers were slowly dying, slowly I mean in millions of years, right? What was expanding were the angiosperms. What do you think the mammals were eating? Well, what do we eat today? Well, we eat angiosperms. So we radiated with the angiosperms, and the only reason we could not grow too big is the dinosaurs would probably eat us. But once the dinosaurs were out of the way, hey, we could expand with what? With the expansion of the angiosperms, and the conifers just were left behind. And it turns out that they got paid in kind because that's exactly what they did to the ferns. See, at one time it was the ferns that covered the planet. Who displaced them? The conifers. So it's a fight of plants. Okay? The plants kill the other plant, muscle aside the other plant, partly. And the other part is that the other plants essentially suffer an implosion. They have to go through this curve. When they get to the top and they start coming down, all the animals which are on that sliding curve, hey, they go down with them. And that might take 10 million years, sure. Okay? But then, where does that leave the comet? Well, that leaves it in fairy tale land, in Alice in Wonderland. Okay? That's where the asteroid belongs. Okay, here's another sample of what happened in Cretaceous. This is in the seas. Okay, and here you see the forams. The forams at the KT limit. They were the old ones. They followed Cope's law. They became the dinosaurs of their world. They were big. And you can see the forams that replaced them afterwards, they were small. Because what? They start out small, they radiate, and they become big over time. In general terms, that's what the curve of life looks like. Okay? So, we have to look at other mechanisms for extinction. And right now we have 200 years in which we have the paleontologists, so-called paleontologists, have no idea whatsoever what causes extinction. Okay? So now you have another theory to ponder. Do you believe it? Not important. Beliefs are not part of science. In science we explain so that you understand, you reach your own conclusions in your own dark basement. Okay? What's interesting is that in that paper they say the following. Okay, so the analysis showed that herbivores tended to disappear first among dinosaurs. Yeah, it should be like that. But it says, herbivorous dinosaurs, of all things, could be responsible for this. The group of hadrosaurs, which were also herbivores, were extremely successful as a group and would have displaced the other herbivores. I don't know. I have another paper out there, and it says more or less the following. Says that the Campanian, which was 10 million years or so before the end of the Cretaceous, you had several species of ceratops, like the Triceratops and so on, and several species of hadrosaurs. And by the end of the Cretaceous, there were fewer. Okay? So this is what another paper says. This is the picture. And so you say, well, Bill, who is correct? Who is right here? Well, I can't tell you who is right. I can tell you that these people, the people who wrote those other papers, they went to Hell Creek, Montana, where, apparently the dinosaurs made their last stand, the big guys like T-Rex and Triceratops. And they did a study, and this is the conclusion they reached. And so you have some people who say, these folks of this new paper saying, oh no, the hadrosaurs muscled everybody aside. And the other people say, no, the hadrosaurs also disappeared gradually. Who is right? I don't know. I can't tell you which one is right. I'm just telling you that science is not about numbers. Science is about telling me what the cause of extinction was. And if you're going to put all the ideas in one basket just to get your paper approved and say, well, I'm going to pay homage to the asteroid guys. I'm going to pay homage to the climate change guys, also to the competition guys, and all these. You got to be at peace with all of them. What is your paper worth? What is the cause of extinction? Gee, I gave you a cause of extinction. I'm saying it's the overturning of population pyramid of plants, followed by the ecological pyramid, overturning of the ecological pyramid of animals. So you have a direct cause of extinction. The animals essentially, they didn't starve to death like overnight, but they were becoming smaller in numbers, older, having fewer kids, bigger, etc., in a shrinking island. And that's what eventually ended up killing them. At some point, they had to go. There was a crisis, and they went. Asteroid had no role whatsoever in mass extinction. Okay, another fellow brings up another issue, and that's related to the Neanderthals. And so let's go with that. It says, I am curious how you would contest the last 30 years of research on the genetic admixture of Neanderthals and Denisovans in sapiens. Also, raids and rape also occurred. Well, what is this about? Well, I talked about the Neanderthals the other day. Okay. And what did I say? I said that the Neanderthals did not mate with us. I don't think we mated with the Denisovans either. Okay. But for the last 30 years, as he's saying, all they've been talking about is interbreeding. In fact, it wasn't even 30 years. Okay. It's actually for the last 10 years since Svante Pääbo's and Richard Green's seminal paper on the genome. And they found somewhere close to 2% commonality between Neanderthal DNA and ours. So what does that tell us? That's a number. That's not a cause. That's not a theory. So they say, oh, we have a theory. Oh, what's your theory? The theory is that we got that 2% by interbreeding with the Neanderthals. And yeah, I have a big problem with that because, animals in the wild don't breed, don't interbreed. Especially, we have to determine whether the Neanderthals and us, we were the same species or the same race within a species. Were we the same race? Or we were maybe different races, but within the species? Or were we two different species, meaning that we could not have successful offspring if we interbred? That's one issue. And so, yeah, we got a problem because these people are saying that in the wild, we just went out there and had a lot of fun. That's very hard to believe because the worst enemy of a Neanderthal was another Neanderthal. And the worst enemy of a human was another human. In the jungle, there are no friends. No one trusts anyone. So when you see another human on the other side of the river, he's your enemy. He's hunting in your grounds. So you better do something about it because if you don't, he will. That's the way it works in the wild. And to say that these people, got together, had parties, drank beer, and swapped squaws. You take my squaw today, and I'll take yours. And that they did it with the Neanderthals that were so differently. You look at their structure, their skulls, and so on. Showed it the other day. They're very different. In fact, Neanderthals did not have a chin like we have. They had these protruding brows. Big noses. They were smaller, had bigger rib cages. They were different. Just by looking at them, you can tell they're different. And you don't have to be an expert. And you're saying that we did not recognize them as different, especially when they were nude, probably the woolly man, because that's what Neanderthal probably was, a woolly man. Like, you have the woolly rhinoceros, you have the woolly elephant, which is the, mammoth. And yeah, I think Neanderthal was a woolly man. And here we were coming from Africa, going up there. Why? Because we were probably following the herds. And so we go up there to their hunting grounds. So we're playing on their home turf. They're used to the cold. They have no shoes. They have no clothes. They never invented clothes. They never had needles. And here we come in there. We're freezing because it's cold, so we start probably inventing clothes at the time. And we encounter these Neanderthals. They see us clothed, and we see them like maybe gorillas, and we're going to have sex with them? Think again. Okay, so yeah, I got a big problem with all that. Okay, so here's the papers that you'll find. And I just pulled 4 of them at random just for you to see. And what do they all do? Well, the same that these other fellows do. They have to bow down to and, pay homage to admixture. And so all they've been talking about for the last 10 years is admixture. So it's not surprising that people say, well, admixture has been proven. It's been around for so long. Again, 10, 11 years now. Proven, because before that wasn't proven. It was proven by Svante Pääbo when he put out his genome paper. Okay, and so now everybody, you can see there, what do they all talk about? They talk about gene flow, and the geneticists have taken over paleontology, Neanderthal paleontology, much like Alvarez took over, the KT paleontology. In other words, the extinction of the dinosaurs. He said, you guys don't know anything, let me come in there. He was a bully. Alvarez is known as a bully, and you know, it's important to know also that, and a little in retrospect, maybe I should mention that. And I did mention, I have a video on that as well, by the way. But you know, where did this guy Alvarez come from? Well, it turns out that Alvarez was a guy working with the military, and he was working closely with the Manhattan Project with a bomb. Okay, and he did some work with some quantum nonsense, and because of that, his friends, you know, got him a Nobel. And when they got him a Nobel, he was used that to trash the paleontologists who dealt with the extinction of the Neanderthal, the dinosaurs. And so he came in there and he especially trashed a fellow known as Dewey McLean. Louis trashed Dewey. And because Dewey was a proponent of the volcanic theory, he wanted to do the same thing they did with the Permian, saying that the Deccan traps in India caused the extinction of the dinosaurs, and essentially what's his name, Alvarez came in there, just trashed him, and said, "No, you don't know anything. Get out of here," and just bullied him around, bitch slapped him, so to speak, and that's why today we have the asteroid theory, and the asteroid theory comes essentially from his son Walter Alvarez. They worked as a team, and did they come up with the theory? No. Well, the theory was around at least since the days of Laubenfeld in, 1956. And even Max Laubenfeld didn't come up with this theory either. The theory was, you can trace it all the way back to the days of Georges Cuvier. French guy around that time, I can't remember his name now, he already said extraterrestrial impact must have caused the extinction of these animals that they were finding for the first time in those days. And so the extraterrestrial impact has been around for 200 years. So what did the Alvarez contribute? Well, they contributed what we don't use in science: evidence. We have no use for evidence. Evidence is used in religion to persuade, to convince, to recruit. That's what evidence is used for. That's what the prosecutor introduces evidence into the record so he can convince the jury to vote for his side of the case. That's what evidence is for. But unfortunately today in science, they give more importance to evidence than the theory. They don't care about theories. That's why we ended up with idiotic theories in mathematical physics. You have what? A particle can be at two places at once. The bending of time is gravity. What nonsense is that? And they say, oh, we don't care about that. We don't care about it. So what do you care about? Well, we care about evidence. We go to the lab, we look at, we observe, we measure, we get a number, we have an equation, we publish. That's what we care about. So they don't care about theories. And same thing with these paleontologists. They don't care about theories. They have idiotic theories. And what Alvarez did, he came in there and says, well, I've got evidence. And he was a physicist with a Nobel. I mean, how much more authority than that do you need? Put it behind his son, got his name in lights. So it's known as the Alvarez theory or hypothesis or whatever. Okay, so that's where we are. And I showed this the other day. This is the problem. Here you see how they fudge around with the percentages. Okay, Svante Pablo said 1 to 4%. You have Prover who says 1.5 to 2.1. Then you have Lose in France. They say 3 to 7% percent nuclear DNA that we have today from the Neanderthals. And then you have these other folks over there that say, hey, you know, before 50,000 years ago, we had more than 10%, and then we lost it over time. Okay, and then the other folks there that I mentioned daily, they said greater than 2%. And what do we find today? Well, we found that there's this Ustishim human, Cro-Magnon, I guess you could call him Cro-Magnon, he was in Russia, but 45,000 years ago, and he also had 2%, just like we did. And so, no, there is no evidence that we lost from 10% to 2% over all these years. Today, we found a skeleton dated to almost 50,000 years ago that has the same percentage as we have today. And, you know, they play around with these percentages. And after a while, you don't know what to believe. And especially because they don't have a theory. And the theory that they have to explain how the Neanderthals did it with us in the wild. Okay? Did the Neanderthals come in and rape the women, our Cro-Magnon women? Or was it consensual? Did we have a party, drink beer, and swap squaws? Is that the way it worked? How did it work? Please explain how we do it in the wild. Especially when we're talking about starvation, subsistence level creatures. They live day to day like a lion, maybe they eat once every 3 days, but then they got to go out on the hunt again and hunt something else because otherwise they're going to starve. They know how often they have to hunt. And they hunt in their grounds. They probably mark their grounds, maybe pissing in the trees or whatever, leaving their scents, and like warning others, hey, watch out, this is my hunting ground. And you think a human is going to come in there, start hunting on their grounds and having sex with their wives, or vice versa? I don't know. You better think again. Okay, people who talk about that kind of stuff or nonsense such as that we traded seashells. A guy like John Hawkes says that that we traded seashells for who knows what, for spears, for sex, for what did we trade for? A piece of meat? Nonsense, total nonsense. That's all you read about in paleontology today. Why? Because there are no new ideas. Why? Because it's a system. You have to publish what the previous guys already proved. You have to use that as a foundation, as a basis. Otherwise, you don't get published. That's the way it is. And so we've got a wrong system for developing science, theories, explanations, rational explanations. Okay, here's the National Geographic. And what did he say about the Denisovans? It says, ancient girls' parents were two different human species. Oh, they made a big fuss about this. 2018, a couple years ago. Not long after modern humans left Africa, they likely began breeding with Neanderthals. Today, around 2% of DNA from most Europeans and Asians is Neanderthal. Yeah, but they never tell you. See, if they told you that, you would start suspecting. But see, they always let it die by pocket veto. It turns the American Indians and the Papua New Guineans have more Neanderthal DNA than Europeans, or Africans for that matter. But they never explain that, and they say, oh, that's interesting. That's quite stunning to discover that. Yeah, don't tell me it's stunning. Explain it. Because if you're going to explain your theory based on the fact that Europeans should have more Neanderthal DNA than the Africans, great, no problem. Okay, you prove that. Great, we prove it. We got a proof, evidence. Now explain the other evidence, why the Papua New Guineans who never set foot in Europe have more Neanderthal blood than we do, than Europeans like me, European origins, or the American Indians. How did the American Indians end up with more Neanderthal blood? Did the Neanderthals go to the Sioux or the Apache and have sex with them as well? Is that how they got it? So yeah, this is the problem. The problem is that it's selective information that they feed the public. Because if people out there knew that the American Indians and the Papua New Guineans have more Neanderthal blood than the Europeans, a lot of people will start questioning. Okay. Anyways, hints of Denisovan also remain. 4 to 6% of modern Melanesians genomes come from this ancient hominid. So how did the Melanesians? How did they ever end up with up to 6% of Denisovan DNA? Please explain the mechanism. Did these humans have sex with the Denisovans and then go to Melanesia? Again, these people never explain how interbreeding happened in the wild. And that's what we want to know, that theory. We want to understand how that happened. Please show us the film, step by step, how that happened. That's what then we would believe in your theory, right? Okay, or even give it any credit whatsoever. Okay, here's another one. Again, Denisovans. Here you have Denny. Oh, good old Denny. She was a Denisovan. Mitochondrial DNA, which was found to be fully Neanderthal, indicating she was a daughter of a Neanderthal woman. Remember, this is a Denisovan. Okay? A nuclear genome revealed her father to be Denisovan. So she's a half-breed, okay, between Denisovans and Neanderthals. Okay, and but with some Neanderthal ancestry. Well, it makes you wonder: was it her father a Denisovan or a Neanderthal? Okay, because there was some Neanderthal ancestry. And what does Pavo say to that? He says, when these groups met, they actually mixed quite freely with each other. It was love, love in the wild. They all had parties. They all got together and say, let's forget our differences. Let's forget the fact that we've marked our hunting grounds. Let's all share this woolly that we hunted. Cost the life of my grandfather, who was there as well. But why don't you join us and let's all eat together and have a party and have sex? Is that how it happened? I mean, you look at the chimpanzees today, and the troops invade another troop, and they kill them all. They kill all the males, and the youngsters, the old ladies, and they take the girls. They're not stupid. The young girls they take, and then they enrich their DNA. Okay, so that's how a lot of this happens in the wild. It happens through violence, probably rape, but not rape like, again, a lone person out there having sex with a gal or whatever. That's not the way it happens. The way it happens is if there, it can't happen in that way, because a female would not leave her clan beyond shouting distance. Because you don't know, not because you're going to find a Neanderthal out there that's going to rape you, but because you don't know if you find a lion running out there. So you have to be at least within, there's no 911, no phone, so you have to be more or less within shouting distance. You can't leave your clan too far away, any of the members. Because if he's out there, he could be struck by anything, and if he needs help, the other guys have to come in with their spears and help him out. So if there's a bear or whatever, they have to kill him. And so the guy has to fight as much as he can until he has some help. And so no one left the clan too far away. When they went out there, they went out to the hunt together. They went together, they came back together. Some of them with half a limb. But for sure, you don't leave the clan. So there's no opportunity for rape in the middle of nowhere. It doesn't happen. Now, there could have been, you could say, a one-night stand. Will that cause the demise of the Neanderthal, the disappearance of the Neanderthals? No, in order for the Neanderthals to disappear, every last one of the Neanderthals had to have sex with humans. Because if they have sex among themselves, we would see a Neanderthal today. No, at some point, all Neanderthals had to have sex, that, had babies, right? Had to have sex with humans. Otherwise, the Neanderthals would not disappear. Is that what happened? We mingled with all these cavemen? They just welcomed us into their kraals. We went in there and just embraced and said, let's share our bounty. And obviously, the Neanderthals did not go south because, they were like the polar bear. They lived in the Arctic. They had enough food for themselves. If anything, humans were following some kind of herd and ended up in Europe. They were the ones migrating. The Neanderthals were more or less sedentary. They had no reason to go anywhere because they had the food right there in front of them. They had maybe, mammoths and buffalo and whatever they hunted. So they had no reason to leave. On the other hand, the humans were coming into their territory, and I'm sure the Neanderthals slaughtered the first humans who encroached on their lands, which again must have been just a little party of a clan that ventured in there in the wrong place at the wrong time, and they got killed. The only time humans were able to really get into Europe was when the Neanderthals were out of the way. How did they die? Their population pyramid overturned. Their genetic diversity disappeared. They were clones of each other in the end, and we had this overturning of their population pyramid. Okay, so let's see all the evidence we have from the Denisovans. Okay, here it is. This is it. I didn't write this, okay? I just copied it. Okay? It says scientists have extracted all we know about Denisovans from what? From just 3 teeth and 1 pinky bone. I didn't write this. This is all we have from the Denisovans. So we have 4 bits of information, a little more in the sense that they did a genome on one of these, and they were able to figure out that these Denisovans were a different species. And from this meager data, we've had at least 10 years or so of theories, of opinions, really. And they all have to do with the same thing, that we interbred with them, they interbred with the Neanderthal, the Neanderthals interbred with us. Why? Because they could never figure out how the Neanderthals disappeared, and we have the same situation as with the KT extinction. Today, they cannot give you a rational theory of how the Neanderthals disappeared or how the woollies disappeared. And so it's either us, we killed them, we interbred with them, we outcompeted them because of climate change, famous climate change. What else can these so-called paleontologists think of if they have to parrot what the previous generation bequeathed to them? And if they don't do so, they don't get an advisor for the PhD thesis, and they don't get to publish. Their career is over. So they have no other choice but to, bow down and pay homage. This is the problem. It's the system we have for determining, for coming up with theories. And again, if someone comes up with a new theory, he doesn't get published. They won't allow it. Okay? So you'll never hear of any of my theories out there because, I'm not part of the mainstream. Okay, so let's continue here with the Denisovans. Some interesting stuff that you'll see out there. They published a paper, I think it was in Russia, and this is the little piece we got in the West. They found a needle in a Denisovan cave, which is over there close to Mongolia. Okay, and the needle is seen as providing proof that the long-gone Denisovans, named after the cave, were more sophisticated than previously believed. Oh yeah, if they can make a needle like that, 3.5-inch needle with a little hole in it, man, they must have been very sophisticated. We have found needles before, but in younger archaeological layers, says one of the discoverers of the needle. Yeah, I think there's been a lot of contamination where you got layer 11, layer 3, and they kind of mixed them up, so we don't know where that needle came from really, okay? But they say this needle came from a layer that dates to 60,000, I think it's 45,000 years ago. I can't remember now the date, somewhere in there. 90,000 years. What is it? 50,000 years ago. Okay? Okay, it predates by some 10,000 years an intricate modern-looking piece of polished jewelry, bracelet made of chloride by the Denisovans. What are they talking about? What is this bracelet? Well, here's the bracelet, okay? Here's the bracelet, and you make up your mind if these people are talking any sense anymore. This is the bracelet. Bracelets showed the Denisovans to be more technologically advanced than Homo sapiens or Neanderthal. Scientists found that a hole had been drilled in part of the bracelet with such precision that it could only have been done with high rotation drill similar to those used today. And people believe this stuff. This is what's incredible. Needle, 50,000 years ago or so, bracelet of that quality there. What do they have, jewelers who made these things? How did they do it with their stone tools? I mean, these guys were approximately in the age of Mousterian technology, which is what Neanderthals used. And these folks are telling you that they had the ability to make these tiny holes in a needle and to mold such a beautiful piece of bracelet, of stone there, right? In such a way that it's even polished. Okay? So what can I tell you? If you believe this, you might as well believe in Alice in Wonderland. Okay? So this is the problem. And here's in comparison, you see there's this competition. Who's the first to discover what? Oh, I'm the first to discover the needle. Oh, no, you're not, because I discovered another needle which predates yours. And here's the Cebudu needle. Okay, and this is from South Africa. Okay, and again it says the Cebudu polished piece has use where reminiscent of that on bones experimental used to work animal hides. These people are suggesting that 61,000 years ago, where this needle was found in that layer, in that reference frame, okay, was used for sewing. South Africa. Now, would they need clothes in those days in South Africa? Well, I don't think so. I think that here we're talking about, probably some kind of human, maybe Neanderthal level human, or maybe Heidelberg level. You have Rhodesian man. He's the Heidelberg counterpart in Africa, or so they say. And so here's this animal, essentially, living in the wild out there, and he's going to sew clothes. What for? Why does he need clothes? I think that we invented clothes and needles when we started venturing into Europe. And for sure we won't find a needle among Neanderthals. They never did. I mean, here you have all these sites. They found Neanderthal bones. They found lots of their tools. They never found a needle among Neanderthals. You would say, with so many sites, they found all these bones, they found all these skeletons, they found animal bones, etc. They never found a needle. A little, even, I don't care if it's 3 inches or whatever, it doesn't matter, but with a little hole inside the wood, inside the bone, they never found that. And they never will, because Neanderthals did not use clothes. They had no use for needles any more than, I don't know, a polar bear has use for clothes either. So it's all this nonsense that these people publish. Why? Because they want to get their names in light. They want to be the first to find the needle. So it's a competition for finding needles, and everybody forgets about the theory. Nobody talks about the theory. They just talk about the finds. That's the problem. Okay, another fellow raises. Let me show you something else here. One fellow raises this issue about the Neanderthals being in Israel, in Iraq, in Syria, in the Levant, in this whole area, Middle East. And I'm saying, no, Neanderthals had no reason to go down there. I mean, what did they do? Do service camel jockeys down there? Neanderthal was a polar bear. He lived in the Arctic weather. That's what he was used to. He didn't wear clothes. He didn't wear sandals. He walked in the snow. He slept in the snow, just like wolves do today. Wolves sleep in the snow. And this animal, who's a polar bear, is going to venture all the way south when he's got all this food up there, all these mammoths and buffalo that us humans, our forefathers, went there to hunt in their territories. So we go up there, and now these people are going to come down, these Neanderthals are going to come down to Israel? No, I don't think so. Okay, I don't think it ever happened. Is there a problem with the sound? Let me see here. Am I having a problem with the sound? Please confirm if there's a problem with the sound. I hear someone has a problem with the sound. I can't hear you anymore. Someone says audio works. Oh, it could have been because I show all my number. I keep having this problem. Somehow YouTube doesn't work, has a problem. Okay. Okay, thank you. Let me continue here. Okay, here's, just for those who want to look this issue up, okay? Here's Ahrensberg, and he's more or less an expert in the Middle East Neanderthals, okay? And this is what they have to say. This paper was from 1998, but I think it's still strong because, see, they try to push these papers underneath the rug, okay? But he said there is actually little evidence for the existence of a Southwest Asiatic Neanderthal population in Israel during the Middle Paleolithic period. Human fossils originally labeled as Neanderthals were subsequently reevaluated and defined otherwise. So people have problems distinguishing between Neanderthals and humans, obviously. Parts of bones, they say, oh, it's a Neanderthal. No, it turns out it's a human. So they have all these errors out there, and you got to be careful about all this because, again, they want to make extraordinary claims, okay? And it says a horizontal mandibular foramen, which characterizes 61% of the Neanderthals, is absent in, and they mention 3 sites. So if you read that paper, you'll find a lot more arguments. They're saying that the fossils that they found in the Levant are not Neanderthals. There's too many differences between the Neanderthals or the bones, the fossils they found over there compared to the ones they found in Western Europe, in Spain, France, Belgium, Germany. Those over there are different, are noticeably different than those over here. So I think what we're talking about is 2 different species. There's another species out there running around. Maybe there were several. You know, maybe there were different types of humans that originated in different parts from the Homo erectus, who apparently walked all the way east to China and all the way west from Africa, right? All the way west to England. So, you know, from there, it's very likely that the Denisovans came out maybe in the middle of Russia. Maybe some others came out in somewhere in the Levant. And then you had us humans, our forefathers, who apparently came from Africa. There could have been several humanoids in different parts of the world, except in the Americas. They haven't discovered America. Columbus had not discovered America yet. Okay, just one final note there. Here we have the Derier, and this is thought to be a Neanderthal child. And I look at it and it doesn't look like a Neanderthal at all, to me at least, okay? Now, you can say, Bill, you're not an expert, okay? I'll concede that. But all I can tell you is that other paleontologists think the same thing. It says 2 individuals of burial number 1 and number 2 share many Neanderthal anatomical features, but display several differences in some traits as well. In the cranium and dentition, the Dederia 2 would be expected to have more definitive Neanderthal features, which are commonly found in the European classic Neanderthals. And they go in there and if you look at the paper, it goes into more detail of the differences. And so all I'm saying is that you got to be careful, because these people talk about the Neanderthals, the Levant Neanderthals, the ones in Israel, Syria, and Iraq especially. And I don't know if these were Neanderthals. In fact, I dismiss them. They're not. They can't be. They can't be, not because I don't agree with them, but because I cannot imagine Neanderthal being born in the Arctic like a polar bear and walking all the way to the equator to do what? When he's got all the food he wants up there, because humans went in the opposite direction because they were probably starving to death and they were walking into Neanderthal territory, maybe following the herds, maybe seeking, I think it's got to do with food, any way you look at it. Okay, another issue that someone raised, there's zero possibility that the women's consent would be a factor, talking about rape or consent, right, whether sex was consensual. The Neanderthal could just kill all the males and abduct the females, of course. After all the males were dead, the women would rather go with the Neanderthals than not go with them, because if they didn't, they wouldn't be able to survive. Okay, so that's how the women got trapped. And so I can show you is my take on that. And here's, okay, was it a case of rape, or, you know, did the Neanderthal just take the girl and take her to his cave? Or was it that she went voluntarily, you know, just flirting with him? Is that how it happened? And how about us? How did we deal with the women over there? Well, maybe we probably ran away when we saw a Neanderthal woman. That's my take on this. I sure pity any human forefather of mine that saw one of these so-called Neanderthal women, and either he had bad eyesight, saw her in the night, and then woke up the next morning and said, "Oh my God, this is what I slept with." Okay, so yeah, the way I look at it, these are the 2 possibilities why we ended up with 2%. Okay, we either had sex 50,000 years or so ago, 45,000 years ago, or the 2% comes because we had a common ancestor, very likely Homo erectus. We do have footprints, at least, of some bipedal animal in England 800,000 years ago. And so we have to assume that there were Homo erectus in Western Europe. From there, the Heidelbergs came, and from there came the Neanderthals. That's my take on that. So Neanderthal was born, as far as I'm concerned, in Europe. He had no reason to migrate out of there. He had enough food. He was a cold climate animal, gorilla, some kind. And we, on the other hand, we were nomadic. Why? Because we couldn't find enough food. Or maybe we were just following the herds, and we ventured into Europe. Why did we come in, what, maybe 35,000 years ago? Because by that time, the Neanderthals were dead, were no longer around. Other than that, the Neanderthals would have killed us, would have murdered us, our forefathers. Okay, one fellow says, this is the punchline, says, Neanderthals didn't disappear, they became politicians. Well, I disagree with that as well. I'm saying they became people who are known today as paleontologists. Okay, what are my conclusions? Well, here it is. Conclusion: Denisovans, Neanderthals, Cro-Magnons. No, as far as we're concerned, these never met or intermingled or had sex or married. There's no evidence that Cro-Magnons were in Europe before 35,000 years ago. There's no evidence that Neanderthals disappeared lived beyond 40,000 years ago. In other words, the Neanderthals died 40,000 years ago. We came into Europe 35,000 years ago. What am I saying? That's the objective data, at least as far as humans are concerned. Right now, all we can trace to any level to any degree is that we were in Europe maybe 35,000 years ago, maybe a little earlier, maybe 38,000 years ago. We were there just about the time that the Neanderthals were about to leave. Mousterian technology dies 40,000 years ago if we listen to Tom Hyam, who's the expert in dating fossils. Okay? There's no skeletons or skulls of Denisovans. All we have is a pinky and, what is it? Three bones, three other bones there. That's all we have. We don't have anything from the Denisovans, almost. So we don't know what they look like. We have no skeleton. We don't have no skull. Okay. Paleontology, but it doesn't matter anyways. Again, you have to explain the theory. How did the Neanderthals mate with the Denisovans? How did we mate with either of those two species? That's what you got to explain in the wild. And if you can't explain that, I don't care how much commonality you find in our DNA. There's other explanations for that, and one of them, of course, is that we had a common ancestor way back when, 800,000 years or so ago. Okay, paleontologists, geneticists make outrageous claims to what? For careers, money, and fame. Geneticists are gophers. That's all they are. Is Svante Pavo a scientist? He's a geneticist, but is a geneticist a scientist? Well, not if all he does all day is count atoms. You know, I mean, if he's got a machine that does the counting for him and he just compares base pairs and so on. Yeah, that's gopher type of work. That's lab work. The scientist sends the lab boy to do that kind of work, says, go count atoms for me and give me the results. So Svante comes back and says, here, boss, this is what I found. So many base pairs, so many molecules. Okay, you can leave now. Let me think. I'm going to figure out what happened. A scientist is a detective, a guy who tells you what happened. And these people, you know, they think that because they can count atoms and do some fancy footwork with genetics, that they're scientists. Well, the fact that they can count atoms, the fact that they determine that 2% commonality between our DNA and Neanderthal DNA, does that allow them to conclude or extrapolate that we had sex with them? I mean, what should we conclude with chimps who have commonality with us as well? I mean, we have commonality even with a fruit fly if you go far back enough. So how did we have sex with these animals in the past if we have commonality with them? Is that what we're going to conclude? That because there's some commonality with the dogs, we had sex with the dogs? Or the cows? What is this? Nonsense. You have to come up with a mechanism, a theory of how that happened in the wild out there. Okay, Admixture created a cottage industry for whom? For the geneticists. Because they took over the Neanderthal extinction business. And today it's all nonsense. It's all about, oh, what diseases we inherited from them, what diseases we gave to them, how much DNA do you really have from the Neanderthals. Everybody goes out there and says, oh, check my blood. I want to know how much Neanderthal blood I have in me. Well, you should come to me. I'll tell you have, right off the bat, without any machine, you have at least 50% Neanderthal blood in you, and probably comes all from your mother. Okay? It is known as political science. That's what these people are doing. They don't do science, they do political science. A lot of politics. That's all it is. Just getting your theory through so that you get your name and lights, your career up and running, your money, your fame. That's all it's all about. It's got nothing to do with science, with extinction theories. They don't have an extinction theory for Neanderthal, for Woolies, for the KT extinction. They don't have a theory for Permian. They don't have a theory for any. Not one that will stand the rationality. Okay, Permian, what is it? Volcanoes. Okay, great, volcanoes. So how did volcanoes do selectivity? How did it kill these animals, chronologically older animals, and leave the new animals alive? Now that's a smart, very smart volcano can do that, right? Okay, Admixture has yet to explain how animals in the wild smoke the peace pipe. Okay, so, yeah, don't tell me that we did it. Tell me how it happened in the wild. That's essentially it. Okay, let's get on with Schrodinger's cat. A little overdue. Sorry I extended it a little bit there, but lots of questions. I wanted to make sure I covered a lot of these little details. Okay, we've been talking about what? Incoherence. Oh, I'm sorry, they called it decoherence. I call it incoherence. Quantum incoherence, what is that? Well, particle at two places at once. Now, how rational is that? Photon is simultaneously both an extended wave and a point corpuscle. It's known as duality, okay? Complementarity, both at the same time. It's that before you measure it. Then it collapses to one or the other. In fact, in the case of the photon, it always collapses to a particle. It never collapses to a wave because a wave is a verb. Can't collapse to a verb, it's got to collapse to a noun. Turns out the photon's not a noun either. Photon is what? A zero-dimensional whatever, and that's not much of a noun there. Okay? So yeah, that's incoherence for you. We've covered that a couple weeks ago. Here's entanglement, what came after that. Here's entanglement. In a nutshell, entanglement, particle here affects particle there. Without physical mediator. There's no physical mediator. One is going counterclockwise, the other clockwise, then they switch around and the other one instantaneously turns in the other direction as well. And there's no physical mediator. How did it do it? Magic? Black magic, is that what we're going to call it? Yeah, it's instantaneous action at a distance, and they could never explain, they never will. How do you explain it with particles, with discrete particles? How do you explain action at a distance? How is a particle affected by another particle if they're all separated by space? Well, that's easy. All you say is, well, you put more particles in between. They come out of space that turn into two particles. You know, space is made of two particles. Space is nothing, so we have black and white particle, and they get together and they form a no particle, and then the no particle divides into a black and white particle. That's great. Tell me the process. Tell me the mechanism, how it does it, how Mother Nature does that magic trick. If you can't explain that, you've got nothing. You just spent saliva. Okay, then we came up last time around with superposition. What's superposition? Well, the horse gallops and stands still at the same time. How does that happen? How can a horse run, even if in the same place? Okay, I'll concede that. Okay, here's the horse running in the same place and at the same time standing still like a statue. What sense does that make? How can you picture that? I mean, I try to picture it, but I'm very creative. No, you cannot imagine a particle that vibrates and it doesn't vibrate at the same time. Makes no sense to say it's vibrating and not vibrating until you measure. As soon as you measure, it collapses to one or the other of these states, quantum states. So all these they're nonsense. That's what they are. And so here we have, where did it come from? All this from this gentleman, Niels Bohr, okay, principle of complementarity. And that's essentially the foundation of this thing that they shorten to duality. You know, light is both a particle and a wave at the same time. They don't say it like that. They say it behaves as if. Well, you're saying in different words that it is, because that's what you're simulating, what you're saying with. You're saying here's a particle, here's a wave, until I measure. Then it collapses to one or the other, and it always collapses to the particle. That's the duality. And what is this? What did good old Bohr say? Well, he said essentially it's an essential, this complementarity, it's an essential feature of quantum theory. Okay? And objects have pairs of complementary properties which cannot be observed or measured simultaneously. Specifically, they're talking about what? Position and momentum, energy, time. They have a couple of these dualities out there, okay? They like all this stuff because they say it gives them something to work on, it gives them job security. Okay? Measuring one quantity of a pair, for instance, the position of an electron, excludes the possibility of measuring the other, for example, momentum. Impossible to have a sharp separation between the behavior of a system and its interaction with the measuring instrument. That's what complementary is all about. In other words, they have no clue. Or like Mr. Feinstein said in the 60s, he said, no one understands quantum mechanics. And what is he saying? He's saying if you don't understand it, you cannot explain it. That means you don't have a theory. So you're not a physicist, because a physicist is a scientist, and a scientist is someone who explains. If you cannot explain, in the case of physics, a mechanism, a cause, you are not a physicist. If you cannot explain how magnetism does its magic, if you cannot explain how a particle can be at two places at once, you can explain how time warps in general relativity, right? Then you haven't said anything, because we're interested in the hows and why and the causes and mechanisms. That's what physics deals with, not with math, equations, descriptions. Okay, here we have Mr. Heisenberg. He put in the other grain that comprises what we know as the Copenhagen interpretation, a brainchild of Mr. Bohr. It says there is a limit to the accuracy with which the position x and momentum p of a particle can be predicted from initial conditions. And he came up with this equation that says the more you know about one, the less you know about the other. Okay, so this is one of the foundations. All these are foundations of quantum mechanics. This is what these people believe. This is what people spread out there. And this is how they explain. These are the physical interpretations that they're giving you. Okay, that's what we need to wrap our brains around. These are the physical interpretations. So here we say we try to measure here, and because you can measure here, you don't know what's going on over there. And Einstein said, no, we should be able to know what's going on over there, because if we can determine the position here, we should be able to, without measuring, we should be able to know what's going on over there. And, Bohr came back with an answer to that. But essentially, this is what Heisenberg proposed. He says, the more you know about one, the less you know about the other, position versus momentum. I like to call it as follows, because what is position? Location. What is momentum? It's motion. So we have location and motion. And so they say the more you know about location, the less you know about motion, and vice versa. No kidding. If the ball is standing still, it's not moving. And if it's moving, well, it's not standing still. And the funny thing is they had to come up with an equation to explain that. And so this is the way I like to put it. Here's good old Heisey. And it says, when the ball stands still, it doesn't move. And when the ball moves, it doesn't stand still. Yeah, no kidding. Do we need an equation to understand this? So this is what Heisey proposed. And so, you have Einstein and his buddies, Podolsky and Rosen. They came up with this. Let me get back in here in a second here. And he came up with this paper, 1935, with his buddies, Podolsky and Rosen. And they criticized the Copenhagen interpretations. What are you people saying? Are you saying that, we cannot measure exactly And Einstein's argument was that even if we don't measure, hopefully what's occurring out there, Mother Nature is in control of that. She knows what's going on. Maybe we don't know. We don't know how to measure. We don't know how to take that measurement, in the microscopic world. But hopefully Mother Nature, Father Universe, the devil, one of those guys has to know what's going on in reality. Again, so they said quantum particles must have position and momentum even without being measured, and so quantum mechanics must be an incomplete theory. It's known as the incompleteness argument raised by Einstein and his buddies. The faraway particle must have precise values of both quantities, whether or not that particle is measured in any way. That's essentially his argument. What did Bohr say? Well, he came back with a stunning reply. He says, well, Einie, you're wrong. Measuring momentum does not allow the observer to automatically transfer or extrapolate, right, this to an inference of position of the other particle. So this is what he's saying, it just is. That's the way it is. And Einstein had a problem with that because he says, that doesn't make any sense. And Bohr just replied, well, we're not supposed to make sense. In other words, we're not supposed to understand the common sense of Mother Nature. That's essentially what his argument was. And so you have Schrodinger, and Schrodinger was a buddy of, Einstein and all these other folks. He said, this is what the Copenhagen interpretation is saying. What these people are saying is that, and he put it in classical terms, he put it in terms of macro items in the famous Schrodinger cat. And he says, look, a particle is merely a probability function. That's what he was saying, that this is what the Copenhagen folks were saying. Okay, Schrodinger's cat is an analogy for a particle. So we're going to use a real object, such as a cat, to explain, to illustrate what these people are saying in quantum, just in case you missed it. Okay, the particle is described by a wave function. It's described by a wave function. So they're talking about an equation. What is an equation? A verb. It's not a noun. The equation is a verb. It's a snapshot or coded way of presenting motion. That's what an equation is. Okay? So equation is always a verb. The wave function proposes that a quantum particle is spread out and occupies all of space. Okay? So here we have this wave function. It occupies all of space. It's like the cat occupies all of space. Schrodinger's cat. Okay, this distinguishes it from the classical corpuscle, because the classical particle looks like this. It looks like a ball. Okay, that's not what a quantum particle is. Quantum particle is an equation that when you touch it, when you try to measure, when you put your little measuring stick, meter stick towards it, it occupies the entire universe. It's spread out. They call it a field, value at each point in space. So it's condensed and at the same time spread out. They covered all the bases. They had to make sure that they could cover all the bases for their equations. Okay? And so Schrodinger put what happens to a micro subatomic particle in macro world terms. That's what he did. Okay? He said, look, this is what the Copenhagen guys are doing. I'm going to do it with my cat. The cat is both dead and alive until you open the box. In other words, until you see, you observe, you measure, you detect. Schrodinger wants you to understand how absurd the physical interpretations of quantum mechanics are. So it's not only, decoherence. It's not only entanglement, action at a distance without a mediator, black magic, I call it. Okay, it's not superposition. The fact that you have these on the one hand, it's hold on, let me get something here. Give me a second. Okay, folks, I got some big problem here, major problem. I'm going to have to cut it short today. So I will see you next time. I wasn't able. Well, let me finish here. You'll hear my voice in the background, but I got lost. I'm not here anymore. I'll just give you my conclusions of this, okay? As a final thing, it's and this conclusion are all quantum physical interpretations, decoherence, entanglement, superposition, complementarity, and uncertainty are all irrational. Schrodinger devised an analogy in macro terms, okay, to ridicule Bohr's Copenhagen interpretation. And it's known as Schrodinger's cat. Analogy, you could call it, okay? Despite the blatant attack on the Copenhagen interpretation on rationality, most mathematical physicists today, physicists with quotations there, subscribe to it. That's what people believe. This is what they explain out there. What does it say about the mental capacity of mathematical physicists to elucidate the workings of the universe? Should you believe in them? Should you put your hand in the fire for these people when they cannot tell you? They cannot tell you, what, and they cannot explain to you any of these phenomena because they can't see it. They cannot observe it. They talk about observing being part of the scientific method of physics, and here they cannot observe, but they still give you interpretation. So why do they give you physical interpretations if they cannot? If they cannot, first if they dismiss them as philosophy, and then if they cannot observe anyways. So this is the issue. The issue is that these people are selling you nonsense. And when you put them against the ropes and start battling them, saying, hey, by the way, what you're telling me is nonsense, they say, well, we know it's nonsense, but that's philosophy. Anyways, I'll see you next time, hopefully on Sunday.